I put up a new packet of notes today. Game Program Notes Part 2, May 26. It's going to be starting here, creating a game with specialty bitmap functions, collision detection, and shooting. This is the project that is going over the notes on page 6, and this one is talking about shooting from a bitmap. I'll run the program to give you a sample. Here, the player class is this crosshair on the that I'm moving around. This moving around is happening with the keys. It's up, down, left, and right only. I have collision detection happening on the bounding box of the screen. I do not have collision detection. Notice how it goes behind. Those are what are called the bad guy. And notice that there's no collision detection, and it actually is drawn behind the bad guy. And I have, when I press the space bar, it shoots. And it actually shoots an object that is built almost the same way that this player is. And there is collision detection between what I shoot, which is called the weapon, and the bad guy. So there is collision detection with what I shoot and the bad guy. Notice that when I do shoot, it actually doesn't get drawn away right away. It continues to go through. The collision detection is not perfect, and I'll explain that as I go through. If you look over in the Solution Explorer, you will see I broke the game up into the different portions. I have the shooter game.cpp. That is the main program. I have my bad guy.h. That was like the little flying saucer that you saw. I have the player. That was the one that I moved around with the arrow keys, and it looked like a crosshair. And that was with, as I said, moving around with my arrows. The weapon was the smaller crosshair that was kind of teal looking, and it rotated around when I pressed the space bar. And I have the .h files. And then I have the associated .cpp files down in the source files. I'm going to start with my player.h. Here is my player class, and this player class is similar to the arrow class that we created last time. We have our player, and here I do pass the height. I have a deconstructor so I can delete my bitmap. I have in the constructor here, I create my bitmap, so that one's a little bit different. Now you notice that there is no erase player. That's because in this program, I am erasing the entire screen to do the animation. I am not just erasing a portion of the screen. And when we did the arrow game, I erased just the bitmap and then redrew the bitmap. I have my move functions. They're done slightly different than I did last time. I had in the arrow, I had an up, down, left, right. Here I have a move up, move down, move left, move right. I'm passing the width and the height, and in there I'm using the width and the height for collision detection. And versus when I did in the arrow, I use my move arrow, and I pass my width and height in my move arrow to do collision detection. But it's the same logic that I'm using here. I have a get X and a get Y. In my arrow class, I had a get X and a get Y. One of the things that you have here that's new that I did not have in my arrow class was this get bound X and get bound Y. And what that is for the collision detection, is that I am using the get bound X to return what my bounding box is. In here, I only have one image declared, versus when I had the arrow, I had 4 BMPs, Allegro bitmaps declared. For those of you who should know this from computer science data structures, this is what's called a macro, pound if and define, pound define, and then at the end if. That is so this is only compiled one time. We do this so we can pound include this in multiple files, but this can only be compiled one time. If you don't have this and it attempts to compile this player.h file multiple times, you get an error message that says redefinition. So every file that you have, a .h and a .cpp, can only be compiled one time. This macro says, hey, the word player H has already been declared, don't define all the stuff in between here. It's been defined. So this code in here is to say you can pound include player.h anywhere you want, but I only want you to compile it one time. Now I have an X, a Y, just like I did with the arrow. I have a speed, same thing I did with the arrow class. I do not have a direction. That is something that you are going to have to eventually add to this class in one of the labs. I have a bound X and Y. What I am doing is I'm doing the same thing that I did with the arrow class. But this time I'm using a variable to store my bounding box. So bound X and bound Y is really storing the width and the height of my bounding box. So if you take X plus bound X, that is the width of my bounding box. If you take Y plus the bound Y, that is my bounding box height. So I am this time actually physically storing my bounding box, where in the last game I did not store that bounding box. If I go over to my player.cpp, I pound include all my Allegro stuff. I pound include my player.h. I do my deconstructor. These two lines are new for you. These two lines are basically saying AL, this is a new command for you, AL underscore get underscore bitmap underscore with image. This automatically goes to the image file and says what is it. Basically asks the question, what is the width of the image, so it goes there, it asks the image is passed back. Now, if you feel that the image is not a good representation of the bounding box that you want to use, then you would have to change what your bound X would actually be. And I do that later on. But for this one, since I'm not really doing any collision detection with my player, I really don't care at this point what it is. I am using a standard AL draw bitmap, which takes the name of the image that I'm drawing, the X and Y location of where I want to draw, and I am not using any flags. I can use a horizontal or a vertical, or horizontal and a vertical flip, but here I am just saying 0, that I'm not doing any kind of flag in there. If you look at my move up, move down, move left, move right, this here is move up, is I'm decrementing my Y. This is I'm incrementing my Y. I'm decrementing my X. This is I'm incrementing my X. And I'm doing it by speed. In this program, speed is constant, and I have it at 7. That means I'm jumping by 7 pixel points every single time. You notice that I do have collision detection going on in each of the function. This is collision detection with the top. This here is collision detection with the right hand of the screen. And what the collision detection on the right hand of the screen is the height of the screen minus the bounding box of the player. This way the player actually stays within the bounding box, it stays within the screen limits. If I did not have the minus bound, that means the player could actually go off the screen. That the whole entire player would go off the screen, and you wouldn't see the upper left-hand corners where the XY position is actually, the XY position is on the upper left-hand corner of the player. The left side of the screen, and this is for the right side of the screen. We're going to move into the weapons class. We need to pound include the bad guy and the weapon. It's for collision detection and for shooting purposes. I have a constructor that creates my bitmap. I have a deconstructor that destroys my bitmap. I have a draw weapon. I have a fire weapon, and that is based upon a key press. I have the update weapon, and I have a collision, and this collision is really similar to the bullet class and the collision detection I had with the arrow. You'll see the private members are pretty similar to the player class. However, live and speed are the same from the bullet class of the previous game. The angle is because I am going to show you how you can use the rotate drawing and how I got it to animate when I showed you the gameplay. And I have the Allegro bitmap image. In the weapon.cpp, I have my pound includes again. I have my Destroy My Bitmap and my Deconstructor. My weapons classes looks pretty much almost exactly identical to my player class. I am using the same exact code, except for the colors are different of how I created this bitmap. I changed the colors, that was it. It's actually even a 64 by 64. However, when I draw it to the screen, it is smaller because I'm not only drawing it smaller, I'm also scaling it. So I'm using the scale to rotate to draw it. So even that this bitmap is a 64 by 64, I'm actually drawing it a 32 by 32. So one of the big differences that you see is that when I create my bound X and my bound Y is that I actually do not use, I get the width and the height of it, but I divide it by, I divide my bound X and bound Y by 2 because I know that I'm scaling when I draw my image by half. So I don't want my bounding box to be a 64 by 64. I actually want my bounding box to be a 32 by 32. But when I said that you create what your bounding box is, I meant that you have to know when and how to create your bounding box. So I create my bounding box to actually be a 32 by 32.
When I draw the weapon, I only draw the weapon when it is alive. So this live Boolean variable is either true or false. It is originally false, and until the user hits the key press, it does not turn into true. I use the AL Draw Scaled Rotate to draw this, not the standard drawer bitmap.
The first parameter is the image. The second and third parameter is the center, or it's not the center, it's where you want to rotate the image around. If you want to have a clean rotation, it's going to be around the center of the image. So the center of this image, remember that the image is really a 64 by 64. So the center of the image is at 32 by 32. I'm going to draw it at the XY location, and then the next two parameters is my scaling factor. And as I said, I want this 64 by 64 to draw half the size. So I want it to be drawn as a 32 by 32. So I say 0.5, 0.5. Then my angle is, notice that I don't put a number in there, because if I put 90 degrees, then it would stay 90 degrees the entire time. I say angle, and you notice the statement after that says plus equal because I am changing that every single time it draws across the screen to always increment that angle by 0.1. And that's how it rotates because it just always adds 0.1 to that angle and eventually goes off the screen. It starts at 0 and then it says 0.1, 0.2, 0.3, 0.4, 0.5. The bigger, if I go by 1, the animation is going to go faster. So the larger the number, the faster the animation. The smaller the number, the slower the animation. So when I fire the weapon is when I select the spacebar. I need to pass in the player to this function is because I want to fire, when I hit the spacebar, I want to know where the player is because I want to fire out on the right side of that player. I not only want to fire out on the right hand of the player, I want to fire out the right middle of the player. So you notice how I find out where the player is, the X and Y location, so, and then I say, well, what's the bounds of that player? And then I also say, well, what's the middle of the bounds? So this tells me where the firing of that XY location. So this tells me where do I want to fire from. So this way, the weapon comes out of that crosshair exactly where I want it to come. And live is changed to true.
Update weapon is a timer function, and it updates based on only the X, and it updates as it goes across the screen. X is increasing, but only if the weapon is equal to true. Once it hits the right bound, then it becomes false and no longer updates.
This portion here is collision detection for the bad guys. Now this collision detection is the exact same collision detection that we did between the arrow class and the bullet class. The only difference is I'm using get bounds, the exact bounding box stuff that I did last time. Now in here I put the for loop inside. Notice how this time instead of passing one bad guy in, instead of passing one bullet into the collision, this time what I'm doing is passing the entire array of bad guys in here, and the for loop is inside of here. So I have one weapon trying to collide with all the bad guys. So the weapon can collide with multiple bad guys after that.